honest, right now, I don't know.
Okay, good. So it's simple. Go ahead.
I finished secondary school very long time ago.
Yeah.
So I can't even remember.
Okay. So in simple terms, an algebra is a form of mathematics that contains numbers and letters.
Okay.
Yeah. So when you have a math question, when you have a math question that contains numbers and letters, that question is an algebra.
Okay.
Have you written that down?
Yes.
Good. So next we're going to look at the parts of an algebra. Parts of an algebra. Let's write this here. So an algebra consists of different parts that come together. If I have 3x squared plus 8, do you think that is an algebra?
Yes, I do.
Why do you think so?
Because it's a math problem that contains numbers and letters and the letter right there and numbers.
Good. So in this math problem, I can see numbers and I can also see at least one letter. But if I have 3 plus 5 minus 7, is this an algebra?
No, it's not.
Because there are so many numbers but no letter, so that's not an algebra. So in this situation, we have an algebra. But this algebra consists of different parts that come together. I can see 3 here, I can see x, I can see 2, I can see 8. All of them come together to make the algebra, right?
Yes.
So the first thing we are going to do is identify these various parts of the algebra, starting with the first part called the variable. The variables. So the variables in an algebra are the letters. The letters in an algebra are the variables. So whenever you see an algebra, the letters in the algebra are called the variables. So in this particular example, what is the variable here?
X.
X is the variable. Number 2, we have the coefficient. The coefficient. In an algebra, the coefficients are the numbers in front of the letters. The numbers in front of the letters. So in this example, what is the coefficient? 3, because 3 is in front of x. So 3 is the coefficient. Number 3, we have the exponent. The exponents are the powers of the letters. The exponents are the powers of the letters. These are the powers of the letters. So in this example, what's the exponent? 2. Number 4, we have the constant. The constant. The constants are the numbers that do not have letters attached to them. The constants are the numbers that do not have letters attached to them. So in this example, what's the constant?
8.
8 is the constant. Okay, good. Okay, so let me know when you're done writing.
I'm done.
Good. Okay, so we've seen four parts of this algebra. We've seen the variable, what the variable is. We've seen the coefficient. We've looked at the exponent and the constant. So we have one more. Five. How do you pronounce this? With my Nigerian accent, some of my students get confused. I don't know why. I just pronounce.
You're not Nigerian.
I just pronounce it and they get confused somehow. When I say terms, they'll say what? I say terms until I spell it. You say no.
Are they Nigerian? I don't know.
Is that?
Are they Nigerian?
No, I mean not Nigerians, like Americans, other nationalities.
Yes, it's terms.
So, but I don't know how I pronounce it, and they don't understand until I spell it. So most times I spell it first, and I tell them to pronounce.
Okay.
So the terms are the small groups that make up the whole algebra. The terms are the small groups that make up the algebra. So they are the small groups that make up the algebra. They are separated by either a plus sign or a minus sign. So you can see that these guys are together, right? And then there's a plus sign here, and then 8 is on its own. So we can say that this algebra is made up of two groups, right? Or two terms.
Right.
Good. So this algebra contains two terms. But if I have something like this, how many groups does this algebra consist of?
3 terms.
3 terms or 3 groups.
3 terms.
These guys here, these guys here, and 11 is on its own. So 3 terms. So whenever you are given an algebra, you need to identify the variable, the coefficient, the exponent, the constant, and the terms. Which sometimes you might not have some of these parts. For example, you might have an algebra where there is no constant, right? Yeah. So, but you must try to identify these various parts. So I'm going to give you 1 minute to read through what we've done. While we are going to be doing a lot of writing in algebra because algebra is a little bit more complex. So with the writing, when you go over it, you'll be able to. It's as if it's a story. You can read it. It combines calculation with the actual writing, so you'll be able to remind yourself whenever you need to. So 1 minute, go over what we've done, then we'll go to the next thing.
Okay, I'm done.
Good. So now we're going to look at things you need to take note of in algebra. So sometimes algebra might seem mysterious because there are some hidden rules that they might not be obvious to the students. So we need to look at these hidden principles. So take note of the following. Number one. So okay. Let me know when you're done writing.
Okay. I'm done.
Okay. So there is always a positive or negative sign in front of a term. If there is no sign in front of the first term, what sign is there?
Positive.
Positive. So if I have 3x squared minus 8x plus 15, how many terms do we have here?
Three.
3. So in front of each of these terms, there must be a positive or negative sign. So you can't have a term without having a sign in front of it. So if you look at 15, which is the last term, you can see that there is a plus sign here. If you look at 8x, you can see that there is a negative sign here. But if you look at the first term, there is no sign in front of it. So when there is no sign in front of the first term, it does not mean that there is no sign there. It means that there's an invisible positive sign there.
Okay.
But if it is supposed to be negative, it will be shown clearly. So, but if it is not shown there, you should know at the back of your mind that there is actually a sign there, and the sign there is positive.
Positive. Okay.
So there is an invisible plus in front of 3x squared. Continue.
Yes, please.
Okay. So the second principle. Done?
Yeah, one moment. Okay.
So the sign in front of a term belongs to that term. If you decide to move the term, you must also move the sign along with it. Why are you moving it along? Because the sign belongs to that term, right? Shadow moves when you are moving. The sign in front of a term must move along with the term. So if I have, so we can see that there's a negative in front of 5x. This negative sign belongs to 5x. There's a positive in front of 3y. This positive belongs to 3y. What sign is in front of 8x?
Positive.
That positive belongs to 8x. So what this principle is saying is, if I decide to move 5x forward and then move 3y back, they must also move with their signs. So if I have 8x plus 5y minus, 5x minus 3y, this will be wrong because I moved 5x, but I did not move the sign along. So if I'm moving 5x forward, it has to come along with the negative sign in front of it. And if I'm moving 3y backward, it has to go with the positive sign in front of it. So that's what this principle is stating. Can we continue?
Yes, please.
Okay. So we'll go to number 3. Have you gotten up to that point? Okay. Continue.
One more, please. Yes, we can continue.
Okay. So every variable has a coefficient in front of it. What is a variable?
It's the alphabet.
And what is a coefficient?
The number in front of the alphabet.
Good. So what this principle is simply stating is, whenever I see a letter, as we call it alphabet, whenever I see an alphabet, there's always a number in front of it. So you can't see a letter without having a number in front of it. But if you see a letter and there's no number in front of it, you should know that what number is there? 1. So if I have 3x plus 5, the coefficient here is what?
The coefficient here is 3.
Coefficient is 3. But if I have x plus 5, what's the coefficient?
1x plus 5.
What is the coefficient?
Is 1.
1. So since I can't find any number in front of x, I should know that there is an invisible 1 there. So this is one of the things that makes algebra seem mysterious. Where a student, you get an answer and they will say, how did you get this? How come you got this? It's because they did not know that there was actually a number here, which is 1.
Right.
So, okay. So, can we go to number 4?
Yes, please.
Okay. So all these things we've done, we've not solved anything. The reason is this is the foundation. If you understand this, algebra will be easier than even fractions once you understand this. So number 4 is similar to this. So every variable has an exponent above it. If there is no exponent above a variable, the exponent there is 1.
Oh.
Continue?
Yes.
Okay. So if I have what is the exponent?
The exponent is 4.
What if I have 3x minus 8?
The exponent with 1.
1. So since there is no exponent here, I know that there's actually a number there which is an invisible 1. Okay. So one more. Let me know what I can continue.
Yes, please. We can go ahead.
No, I can't see you from here, so you have to tell me whenever you're ready for us.
Oh, I'm so sorry.
No problem. That's what I'm always asking. So number 5. Okay.
It says in front of the all the time, you see actual value of the number.
Yeah. Can we continue?
So like plus 8 is the value of the number and minus 8 is the value of the number.
Exactly. So if here we are, if you are asked what is the constant over here,
It's 8.
what is the constant over here?
Positive 8.
What's the constant over here?
8 minus 8.
Minus 8. So over here, the constants are not the same.
Oh, I see. So one is 8 positive, the other one is negative 8.
Negative 8. So if you are asked about the constant and over here you just pick 8, you'll be wrong.
Oh, okay.
So the constant is positive 8. But when it's positive 8, you can also write it as just 8. Do you know why?
Yes.
Why?
Because whether you put the positive or not, if it's not there, it's automatically positive.
Good. So if I don't see any sign in front of the first term, since there's no other term, it is the first term. So if I don't see any other sign, if I don't see a sign here, I know the sign here is positive. So if you say positive 8, you're correct. If you say just 8, you're correct. But once there's a negative, you must say negative 8.
Okay.
Yeah. So in algebra, signs are very important. Continue.
One moment.
Okay.
Yes, please, can continue.
Okay. So I'm going to give you 2 minutes or 3 minutes to go through these 5 things we need to note. Go through it again. And then we'll go to multiplication of algebra.
Wow. Okay.
It's very easy. It's very easy. can let me know when you're ready for us to continue.
Yes, give me 1 second. Okay, we can go ahead.
Multiplication of algebra. So the principle is simple. Okay. So the principle states that when you're multiplying algebra, multiply the coefficients and add the exponent. So let's look at an example. So parentheses, when you have two values like this, 2 and 3, this means 2 times 3 is another way of writing multiplication.
No, can you say that one more time?
Another way of writing, instead of me to write 2 times 3, I can write it like this. This still means 2 times 3.
Oh, okay.
Yeah.
Oh, because of the brackets.
Yeah. Or I can write it like this. It's still 2 times 3. This is different from 2. This is 2.3. This is 2 times 3.
Oh, wow. Okay. I'm seeing that for the first time in my life.
Okay. So the point is down, so it's 2.3. Okay. But the point is at the middle, 2 times 3. Okay. So 2 times 3 can be written in any of these ways. So that means this situation means 3x squared multiplied by 4x to the 5th power. Okay. Good. Okay. So we are multiplying these two algebras. The principle states that when you're multiplying algebra, you multiply the coefficients, you add the exponents. So in these two algebras, what are the coefficients?
The first is 3. Okay. And the second is 5. The
second is
Sorry,
4. What are we supposed to do to them?
Add them.
Look at the instruction.
When multiplying algebra, multiply the coefficients. Oh my God. We multiply them.
So we're going to do 3.
And we add the exponents.
Good. So we're going to do 3 times 4, 12. X. We add the exponents. 2 plus 5, 7. And that's the answer.
No way. It cannot be that easy. Are you kidding?
Yeah, that's the answer.
No. You know what I would have done? Oh my God. I would have overthought it.
Yeah.
So I think I agree with my supervisor said I'm an overthinker. I would have overthought this and expanded the living life out of it.
Yeah.
Not got anything right.
So that's why I said earlier that algebra is very easy. Very easy. Once you understand it, it's very easy.
Let me write that down. And then, so you actually gave me one question on the first day and I didn't attempt it.
Yeah.
I've gone back severally
Yeah.
to look at it, even while you were teaching that. I've been way back there, just to the information you've been
Yeah.
It only just makes sense now.
So can we continue? Are you ready?
Yes, please.
Okay. Let's try another one. Sorry. Okay. 5x to the third power multiplied by 2x. So what are the coefficients?
We have 5 times 2, 10.
10 x. What are the exponents?
3 plus 1.
That gives us
4.
4. So imagine that you did not know that there is a 1 here.
Then I would have filled it because I put 3.
Yeah. So that's why those principles are very important.
Okay, we can move on.
Okay. So I'm going to give you 3 questions to try out before we continue. Be careful with number 3.
Okay. So I'm not saying very clearly. The first one is 3x raised to the power 4, right? And the first one is 4x raised to the power 3.
Yeah.
Okay.
Can you see better?
Yes, I can. Thank you.
No. Okay. So what did you get for the first one?
12 raised to 7.
Say it again.
12 raised to 7.
Is it 12 raised to 7 or 12x?
Oh,
The examples we gave.
The last one we didn't have 12x now. The
What?
first one we had 12, 7.
What was the question we had?
The question we had was 3x raised to the power 3 and 4x raised to the power 5. And then we did 3 times 4, that gave us 12. And then we had x 3 plus 5 equals 7. And then we had 12 raised to 7.
No, you didn't write it the way I wrote it. It's 12x to the 7th power.
Oh, my bad. I didn't write it that way, so that's how I wrote my answer. Okay, so it's the same thing. 12x7. I'm sorry about that.
Yeah, no problem.
My brain is trying to move this morning. So the x doesn't go away.
No. It doesn't go away.
Okay.
4x, 3x. So it becomes 12x. Right?
Okay.
Then you just add the exponents.
Okay. I'm sorry, I think I didn't see that.
Okay.
So the first answer I have 12x raised to the power 7.
Okay. Second one.
4x raised to power 6.
4x raised to power 6, correct. Third one.
1x raised to power 2.
Correct. As an amateur. Okay. This is the one too. Remember, when it is 1 here, do you need to write it?
No.
So it's x to the power of 2. Because as a professional, we know that when there is no number here, we know that there's 1 there.
Okay.
Yeah, so it's x to the power of 2. Okay. So the principle for multiplication is multiply the coefficients, add the exponent. So let's go to division of algebra. So it's the opposite of multiplication of algebra. While in the case of multiplication of algebra, we're multiplying the coefficient and adding the exponent. In the case of division of algebra, we are dividing the coefficients and subtracting the exponents.
Okay.
Example. Eighteen x to the 5th power divided by 6x to the 3rd power. So the coefficients are 8 and 6. What do we do to them?
We divide.
So we have 18 and 18 divided by 6 gives you 3x. The exponents are 5 and 3. What do?
We subtract 3 from 5.
So it gives us 2. And that's the answer. little students that I normally tutor will say easy peasy.
You're right.
Easy peasy. Okay. Can we continue?
Yes, please.
Okay. So if you have so what are the coefficients?
3 and 1.
So 3 divided by 1, what do we have?
3.
3x. The exponents are 4 and 3. 4 minus 3? 1. That's as an amateur, but as a professional,
Oh, you
don't need to write it. Yeah.
Okay.
So the answer is 3x. Okay. We are moving so fast.
I'm glad I'm understanding it. I need to also practice.
Yeah.
Because I really want to understand it in class and then not practice and forget what I'm learning.
At least you have some days to practice before our next class. Our next class is on Saturday, right?
Wednesday.
Yeah, oh, sorry. After Wednesday, then you have Thursday, Friday.
Yes.
You can use that to just go through all that we did in this first week. Okay. So let's try another one. We've done 2 examples in division, so try out questions. Okay. So we haven't learned about these 2 yet, but I want to see what can come up. Why did you make that sound?
I tried to be logical, but I don't think that it makes sense. But I'll do the last one and then I'll let you show.
Okay. Good. So what did you do for the first one?
9 divided by 3, I had 3.
Okay.
And for the exponents, I had 5 minus 1, that gave me 4. So my answer was 3x raised to the power 4.
Correct.
For the second one, I have 24 divided by 8, that's 3.
Okay.
And then 7 minus 2, that's 5. My answer is 3x raised to the power 5.
Correct.
And for the one that made me sad, I had 4 divided by 2, that gave me 2.
Okay.
Then I had the 2 minus 2, it gave me 0.
Okay.
Now, I'm not sure, I have 2 answers.
Okay.
Now, I have 2x 0, which to me doesn't make sense. You went, right?
Okay.
Oh, I have 2x minus 1. I don't know.
2x.
Minus 1.
I should write
minus 1.
I should write minus 1 at the top.
Yeah, minus 1 up there.
The weird one have it.
Okay.
But that's not the final outcome. So it's logical that 2 minus 2 is 0 because you are supposed to, the instruction says subtract the exponent. So 2 minus 2 is 0. But the next thing you need to do is x to the power of 0 means you cancel out the x.
Oh.
So you strike it out. So your final outcome will just be 2.
Oh, wow.
Yeah. So
okay.
if you leave it as x, that means you're saying that there is an exponent of 1 here.
Positive.
So x to the power of 0 means x is gone.
Okay.
So how does that affect your final outcome in number 4?
So how that affects my final outcome would be my last answer would be 1. So that's 3 divided by 3 equals 1.
Yeah.
And then 1 minus 1 because the exponents there are invisible.
Yeah.
1 minus 1, that's 0.
Yeah.
So I have 1.
Correct. Correct. So take note of what we did. The reason I didn't teach you at first is so that to lay emphasis. So when you get it wrong, I then will do it. Okay. So now we've done multiplication of algebra, we've done division of algebra. But remember I told you that the signs are very important.
Yes.
But we didn't consider the signs here. We didn't consider if this is positive or this is negative. We just focus on the numbers. So we're going to look at multiplication of signs. There's a rule that governs multiplication of signs. Okay? So this rule does not only apply to algebra, it applies to arithmetic, every other part of mathematics. So we're going to look at that, the rule, and then we apply it here. sign rule for multiplication. So this rule states that when a positive number multiplies a positive number, your final answer will have a positive sign. Example, if I have positive 2 multiplying positive 3, first to multiply the signs. Positive multiplied by positive will give me positive. 2 multiplied by 3 will give me 6. Right? Next, negative multiplied by negative will give me positive. That means negative 2 multiplied by negative 3. We first multiply the signs. Negative multiplied by negative, positive. 2 multiplied by 3, 6. So what is the summary of this? This tells you that when you're multiplying two values that have the same signs, your answer will have a positive sign. Your answer will be positive. On the other hand, if I have positive multiplying negative, the answer will be negative. So if I have positive 2 multiplying negative 3, first I multiply the signs. It gives me negative 6. Also, negative multiplied by positive still gives me negative. Negative 2 multiplied by positive 3 gives me negative 6. Summary, when you're multiplying values with different signs, your answer will be negative. It's negative. Okay. One moment, please. Okay. I have a question, please. Go ahead. So, like up and down, right? When you have the positive signs up, that you put them in the brackets, is that just for the purpose of the example? Yeah. Because I know you talked about brackets and there being multiplication. Yeah. So the bracket is multiplication, but the reason I separated them like this, if I end up writing plus 2 times plus 3, it might look a little bit confusing. Okay. But I could have also written it as plus 2 and plus 3. Right. But the reason I brought it down is because of this to show that I'm still saying that I'm talking about the same thing.
Okay. Yeah. I just wanted to clarify that. Okay, let me write the second part that I'm ready. Okay, I'm all set.
Okay. So let's look at some examples. So if I have negative 3 to the third power, negative 3 to the third power means negative 3 is multiplying itself how many times?
1
to the third power.
3.
3 times. So if I have 2 squared, it means 2 times 2, right? So negative 3 to the third power means negative 3 is multiplying itself 3 times. So we're going to have negative 3 times negative 3 times negative 3. But we cannot multiply all 3 values at the same time. So we have to multiply the first 2, get our answer, and then use that to multiply the last
one. Okay.
Yeah. So going by what we just learned, since we are multiplying these two first, negative multiplied by negative.
Just negative. No, it's positive, sorry.
Why is it positive? Why is it positive?
It's positive because when you're multiplying values with the same sign, the answer is positive.
It's positive. So positive, and then 3 times 3?
9.
9. So now we can multiply to the third one.
Okay.
Positive times negative?
Negative.
Negative. 9 times 3?
27.
27. So that means negative 3 to the third power is equal to negative 27. So this is not algebra, but we've used it in solving this.
I was just about to ask you a question.
Yeah.
But you already answered.
Yeah. So I said earlier that the concepts are applicable to both algebra and arithmetic.
Yes.
Can we continue?
Yes, but I didn't write the example because I think it's going to mess with me. What I already wrote. I would kind of think it's algebra.
No. You can see that when I wrote this, I erased the topic algebra.
Oh, okay.
Yeah.
Okay.
So you can just cross a line to show that this portion of what you're writing is beyond algebra.
Okay. Okay, give me 1 moment. Let me just write it down. One moment, please.
Okay.
Okay, I'm upset.
Okay. So let's apply this to algebra quickly.
Okay.
So this is negative sign, right?
Mm,
What sign is here?
positive.
So since there is no sign, we know that the sign here is positive. So negative multiplied by positive,
Negative.
negative. So you can see that now we are considering the signs. We are multiplying the signs before we go ahead to do other things. Negative multiplied by positive gives us negative. And the principle of multiplication says multiply the coefficients. So 6 multiplied by 3 gives us 18x. And also we add the exponent. 4 plus 2 gives us 6. Do you understand what we've done?
Yes, I do.
Good. So in this situation now, we are considering the signs. Because in the ideal situation, you need to consider the signs when you're multiplying or when you're dividing.
Okay.
Continue?
Yes, please.
Okay. So let's look at sign rule for division. So the sign rule for division is similar to the sign rule for multiplication. When a positive value, we are not going to write so many things, we're just going to put the signs. When positive divided by positive will give you positive.
Positive.
Negative divided by negative will give you positive. Positive divided by negative will give you negative. Negative divided by positive will give you negative. So when the signs are the same, your answer is positive. When the signs are different, your answer is negative. Just the way we did in multiplication.
Oh, yes. Let me write that down. Okay, I'm all set.
Okay. So let's see an example. So because of the purpose of separating the values, I'm going to put them in parentheses. This parenthesis does not mean I'm multiplying.
Okay.
So the reason I'm putting it in parentheses so you don't get these two signs confused.
Okay.
So negative divided by negative, what do we have?
Positive.
Positive. So we have first of all divided the signs. Then we'll go to the coefficients. 15 divided by 5 is 3.
Is 3.
X.